Hello, my name is Manteja. I am from CSAMLA section. My topic name is the types of entropy and information gain and gain ratio, which is in machine learning. So let's go to the topic and discuss the points and information about entropy. Now let's see some outline or the contents what which we have gonna discuss in the topic. First one is attribute selection, second one is entropy, and third one is subappraisal, and fourth one is information gain, and fifth one is gain ratio, and the next one is pawning and their rules. These are some contents about what we are gonna discuss in going slides. So let's start. And firstly, we will see what is constructing decision trees. Firstly, the strategy is we should go top to bottom and we should use the recursive divide and conquer fashion, and then we should select an attribute for root node and create branch for each possible attribute value, then split instances and subsets, one for each branch extending from the node. Finally, repeat recursively for each branch, using only instances that reach the branch, and stop if all instances have been in same class. And this is from the data set. Firstly, we are taking the weather data set. Here we have taken outlook, temperature, humidity, windy, and play. In play, we should give only yes or no, and in windy, we should give true or false, and in humidity, we should give normal or high, and in temperature, we can give hot, cold, mild, and in outlook, we can give sunny, overcast, raining. And using this, we have created a data set, and we can see some data is here. Let's draw the decision tree for this. And which attribute to select? Firstly, we are taking outlook, which has sunny, overcast, and rainy. And there are some points given there, yes or no, using the play. And here the humidity, they have two types, high and normal. In the both cases, they have given yes or no. And in windy, there are two types, true or false. And in temperature, there are three types, hot, mild, cold. And in temperature, there are three types, hot, mild, cold. And they have given their respective examples. And now we will see some computing purity, the information measure. Firstly, the information is a measure of a reduction of uncertainty. It represents the expected amount of information that would be needed to place a new instance in the branch. This is very important for computing the information. And after computing the information purity, we are only taking the outlook which contains more information rather than the separate information like windy, temperature, humidity. And by this we are rejecting these three and we are only taking the outlook measure attribute. So by using the outlook attribute, we are constructing the final decision tree. By this, we are taking the outlook, and after that, there are two types: sunny and rainy, and overcast. And in overcast, we they contains S, and in sunny there are also two types, that humidity is high or low, high or normal, and there are given their options S or no with their respective humidity. And on the other side we have windy, which contains true or false. By splitting stops when data can't be split any further. And this is about the final decision tree. And criterion for select attribute selection. Firstly, which is the best attribute we should select, and want to get the smallest tree. We should always get a smallest tree by which contains more information. And hysteric, choose the attribute that produces the purest nodes. By using this criteria, we are going to select the attributes. And information gain, which increases with the average purity of the subsets. And the strategy is choose attribute that gives greatest information gain. By using this criteria, we have chosen outlook, which contains more information. And now we will see how to compute information gain entropy. When the number of either yes or no is zero, that the node is pure, the information is zero. When the number of yes or no are equal, then the information reaches its maximum point, because we are very uncertain about the outcome. And there are some complex scenarios that the measure should be applicable for a multi-class situation, whereas multi-staged decision must be madness, multiverse of madness, Doctor Strange, and some Marvel series. And this is an entropy graph. In x-axis they are taken the probability of x equal to 1, and on y-axis they are taken h of x, which is the information. And by using this they have drawn a graph which contains the at 1 there is a maximum information gain, and at 0 and at maximum point of x-axis the information gain is 0. This is about the graph going through the probability and information gain. And now we will see some entropy formulas. Formulas for computing entropy. Entropy of P1, P2 going so on, Pn equal to minus P1 of log P1 minus P2 of log P2 and so on, minus Pn of log Pn, where h of x equal to minus of summation x to infinity 0 x to infinity p of x of log p of x. This is some kind of formula we have gone through the entropy. And the outlook and sunny, which we have taken the example. By using this example, firstly we are taking the first column, which contains SS and no no no. By using this information, we are using the above formula and computing the information, how much bits we have gained the information. As the information is 2 by 3, we are taking the, as the information is two types, yes or no, and the number is 5, and 5 times they are yes and no. So by using the criteria, by above formula, we are computing the information. By solving the equation, we are getting 0.971 bits. This is about the above formula we have discussed. Now we will see some measures, information and entropy measures. And there are many statements in the literature which say that information is the same as entropy. But properly, the entropy is a probabilistic measure of uncertainty or ignorance, and information is a measure of reduction of uncertainty. However, this is a concept context. We use the quantity of the uncertainty to measure the entropy at information node. And this is about the computing information gain. Information gain, information before splitting, information after splitting, gain outlook of information of 90,5, which is minus of information of 2, 3 and 4, 0 and 3, 2. By using this, we have got 0.247 bits information gain for attributes for weather data. So by using the previous formula, we have got the information for outlook. It is 0.247 bits. For temperature 0.0229 bits, and so on for humidity and windy. This is all about the information gain. And there are some drawbacks of information gain. When the attributes are very large number of values, then it is very hard to gain the information. And this is only the drawback we have. And now we will discuss about gain ratio. Gain ratio is a modification of the information gain that reduces its bias. Gain ratio takes number and size of branches into account when choosing an attribute. It corrects the information gained by taking the intrinsic information of a split into account. Intrinsic information about the class is disregarded. And these are some gain ratios which we have seen in the above example. So this is all about the gain ratio of weather data. And this is an separate example where we have taken the subtree replacement, and we are taking the, firstly we are taking first node is wage increase in first year and start with holidays and wage increase in first year. And easy converting a tree into a set of rules. One rule is on each leaf. Produces rules that are unambiguous, doesn't matter in which order they are executed, but resulting rules are unnecessary, complex, and prone to memory redundant tests and rules. and this is about the types of entropy and information gain using machine learning. In machine learning, we have gonna use this entropy and information gain. So this is all about the presentation. Thank you.